For learning objective C, we're going to talk about half-life and how it's exponential decay and how to find it. First of all, what half-life means, it's the amount of time it takes an original quantity to decay to half that amount. Now, there is a half-life formula we use, and it actually does come from just the exponential model formula, so y equals a b to the x. If we start with that and kind of talk about it in terms of half-life, it's going to work the same, except the b and the x are going to be a little bit different. So let me put words in here. The y value is still going to be our ending amount of something. The a value is going to be our beginning amount of something. Now, because it's a half-life, I actually know what the decay factor is going to be. They don't need to tell me that. I know it decays in half. So the b value is always 1/2. Now, the exponent used to stand for time. Well, for time, that means I need to know how many half-lives there were. So the exponent here is the number of half-lives that have happened. So let's just use more of this verbal model to help us set up this first question. So it says here that there was detectives in an investigation found this chemical called polonium on a cup in a hotel that he had visited. And suppose that there were 4 micrograms found on the cup, and it had been there for 30 days. Okay. They want us to find out how much polonium was on the cup originally. So if you think about it, he found 40 micrograms on the cup. Was that the beginning amount on the cup, or was it the ending amount on the cup that he found? Well, this one's a little bit different. That is actually the ending amount. So what I'm going to do is put here that the ending amount is 4. Okay. The beginning amount on the cup, that's actually the question. Find out how much polonium was on the cup originally. So let's just call that, we'll call it P for how much polonium there was. That's our beginning amount. Okay. The 1/2 is going to stay there because it's a half-life. Okay. Then the question is, how many half-lives have taken place? That's what has to go up here in the exponent. Well, to know that, I need to know what the half-life is of polonium and how it works. So polonium, we need to be told this fact, that it has a half-life of 138 days, which means every 138 days it's going to cut itself in half. So here's the question. After 30 days, how many half-lives have actually taken place? Well, in 30 days, that's not even close to 1 complete half-life. So what you're going to do is, to find the exponent, you're going to put the half-life here on the bottom of your fraction. So that'll be 138 days. And then on the top, you're going to put how many days have transpired in terms of your time. So that's going to be 30. So what we just created here is this formula, is that it's 4 is equal to the original amount of polonium, and it's going to have a half-life. Our exponent is 30 days have gone by of 138 for 1 half-life to happen. So to simplify this, what I can do is I can take the 1/2 and raise it to the power of 30 divided by 138. When you do that, you're going to get the value of 0.86. Now to solve for P, or original polonium, just divide both sides by the 0.86, and we will get our answer that the original amount of polonium on that cup looks like it was 4.65 micrograms. Now, let's rewrite that formula again, maybe without words this time. So we're going to have our ending amount is equal to our starting amount. And the difference is the B is not there. It's actually a 1/2 is the base. And the exponent is going to be the time that's passed divided by the length of a half-life. So if we look at an example, here's another one. A certain substance has a half-life of 24 years. By the way, that 24 years just represents the length of the half-life. If a sample of 80 grams is being observed, how much will remain in 50 years? Well, it's a sample of 80 grams that we start with, so that this time is our A. The half just stays there. We have the half-life is 24 years. How much will remain in 50 years? Well, the 50 years actually represents this time length right here. So if we write this formula, how much will remain in 50 years? Well, our ending amount is going to be our starting amount, which is 80. And we want a half-life. Well, how many half-lives have passed by? Well, 50 years have gone by, but each half-life is 24. Folks, if you do 50 divided by 24, that means 2.08 half-lives. So let me actually write that down because I think it's interesting to see this. This is going to be raised to the power of 2.08, which means it's going to do the half-life a little over 2 times. So fine, take the 1/2 or 0.5, raise it to the power of the 2.08, and what you're going to end up getting is that this is going to equal 80 times 0.23597. Take that times 80, and that's going to give us that there will be 18.88 grams of this substance left after 50 years. Now I want to challenge you to see if that's logical. So let's go ahead and fill in a table on this. The number of half-life periods and the time of days, and we're going to change days to years for our half-life. So here's how it works. At the very inception of the substance, the amount present we know is 80 grams, and the number of days would be 0. So when the very first half-life happens, we know this half-life is 24 years. So what's going to happen is 24 years will have gone by. After 24 years, this number of 80 is going to cut in half to 40. Okay? Now another half-life is going to take place, so another 24 years, which means we're at 48 years. In 48 years, this is going to cut in half again to 20. Let's do another one. A third half-life, another 24 years goes by, and we're going to be at a total of 72 years, and the substance cuts in half again. Well, the answer that we computed came out to be 18.88 grams. Does that make sense? Well, this is after 50 years has gone by. Well, the table says at 48 years, 20 grams will be there. So if we let 2 more years go by, the 20 grams will decay a little bit, and the 18.88 actually makes sense.